Hello friends, welcome to online computer classes. Myself Dr. Kajal, and today this video is about operating system and basically the topic of scheduling which I am going to take. I already discussed about FCFS scheduling in the last video, but here I am going to tell it more about something about it and rest of the scheduling algorithms also. And these are the contents of today's lesson, and we will go through all the scheduling algorithms: FCFS, SJF, priority, round robin, multi-level, real-time, all of them one by one. Now first look about some basic concepts of scheduling. First is multi-programming. Multi-programming basically a number of programs that can be in the memory at the same time, and it allows the overlap of CPU and IO burst. Next, jobs. What are jobs? Jobs are basically programs that run without any user interaction, that runs independently. Now, what is CPU and IO burst? CPU IO burst cycle. What is this? Characteristics is process execution, which alternates between CPU and IO activities. CPU times are generally much shorter than the IO times, input output times. And preemptive scheduling. What is preemptive scheduling? An interrupt causes currently running processes to give up the CPU and be replaced by another process. Suppose a process is running, it is holding the CPU time, but then an interrupt occurs, and if it is preemptive scheduling then that the CPU will goes to that interrupt, and that interrupt, after handling that interrupt, then the CPU comes to that scheduling, which leaves it. Otherwise there may be other processes which gets the CPU. This is the case in preemptive scheduling. The process can't hold the CPU for the long time. Whenever the interrupt occurs, it releases the CPU and resumes its execution after getting back the CPU. Now what is scheduler? A scheduler selects among processes in memory that are ready to execute and allocates the CPU to any one of them. CPU scheduling decisions may take place whenever a process switches from running state to waiting state, or running state to ready state, or from waiting to ready states, or whenever a process terminates. These four conditions are there when CPU scheduling needs to be done, and decisions need to be made that which process would get the CPU next. So these all the conditions, and the decision is taken by the scheduler. Now first, there are several scheduling algorithms. First is first come first serves, which we called popularly it is known as FCFS. It is the simplest scheduling algorithm. The process that requests the CPU first gets the CPU first. FCFS is non-preemptive scheduling algorithm. That means it does not have any interrupt will not get the CPU from it. It keeps on running until that process releases it by terminating it. Next is FCFS is suitable for batch operating system. The average waiting time of FCFS is often quite long sometime, and it is not suitable for time sharing system. Basically it is only suitable for batch operating system. Now look at the example of FCFS scheduling. We have four processes, P1, P2, P3 and P4, and they have different burst times, and their arrival time is 0. Arrival time is the time when the process can get the CPU without waiting that number of seconds, or if there are arrival time, that the process have to wait till that number of seconds or milliseconds, whatever it is, whatever the unit is. Now look at the average waiting time of the whole total processes. For P1 the waiting time is 0. For P2 it is 7 because it has to wait until P1 completes. Then for P3 has to wait until P1 and P2 both completes, because first the P1 comes, so it will get the CPU first, then P2 comes, so P2 get the CPU first, then P3 get the CPU, and then P4. It runs like that. So P3 has to wait till 11 seconds, P4 has to wait till 13 seconds. So the average waiting time is 7.75 seconds, and the average response time is also same for this condition because the arrival time is 0 for all the processes, so it is equal to the average waiting time. This is the Gantt chart which is showing when the processes get the CPU at what seconds. This is the Gantt chart for it. I hope you understand what is FCFS. It is very simple algorithm. The process which requests the CPU burst will get the CPU burst. That's it. And sometimes the waiting time is too long for some of the processes, as we can see that P4 has to wait till 13 seconds to get the CPU, and P3 also has to wait till 11 seconds, but it has to execute only for 2 seconds, but it has to wait till 11 seconds. So this is often long sometimes for some processors. Next, look at about SJF, shortest job first scheduling algorithm. When the CPU is available, it is assigned to the process that has the smallest next CPU burst. That means this algorithm needs to know about at what time what amount of time the process needs the CPU. For example, if it needs the CPU for if it has the burst time of 2 seconds, that means the process needs the CPU for 2 seconds. If another process is there and it needs the CPU for 4 seconds, then the scheduler chooses the first one because it needs the CPU for shortest job time, shortest amount of time. So in this way the CPU selects the process which has the shortest next CPU burst. It will give the CPU to that process only. This algorithm is considered as the optimal ones because when it gives the CPU to the shortest job burst process, then that process completes in a very small amount of time and releases the CPU and gives back to another processes in the queue. The problem with this algorithm is that it needs to know the length of time in advance for which the CPU is needed by a process, and to know the length amount of time in advance is a problem. Is not easy to know how much amount of time a process needs the CPU. So this is the main problem for SJF, because predicting the time the process will use on its next schedule is not easy. But it can be done using the given formula, where Tn plus 1 is the time of next burst and Tn is the amount of the time of current burst, and big Tn is the average of all previous bursts. It has to need to take care about the past, how much time that process gets the CPU. So it needs to keep track of all the previous records of it, and then it has to give the calculate the CPU for the next burst, and W is the waiting factor emphasizing current or previous burst. So according to this formula, by calculating how much amount the next process will have the CPU burst, so it calculates according to this. Now let us consider an example of SJF. We have 4 processes and with different arrival times and different service times. Service time is the next CPU burst time, which for how much amount of time as a process needs the CPU, not a service time, or we can say burst time. It is same. So at 0 time, we say process P1 comes and it gets the CPU because it does not need to wait, and it gets the CPU. But at the end of 1 second, process P2 also arrives and it has less CPU burst, smallest CPU burst from P1 and P2. P1 already executed for 1 second, it has left 7 seconds of CPU burst, but 7 is bigger than 4, so P2 will get the CPU and it will execute till it ends, that is at 5 seconds. Then at the arrival of 5 seconds, both processes P1 and P4 arrives at the CPU, and P4 will get the CPU because it has less next CPU burst, smaller CPU burst from P1, P3 and P4 from among three of them. So P4 will get the CPU and it will execute it after completion. P1 has less amount of CPU burst left in comparison to P3. So P1 will get the CPU and after completion of P1, P3 will get the CPU. So the average waiting time here is, first is 0 for P1 but 0 plus 9 because it has to wait again for 9 seconds. For 1 second it has done, so for 9 seconds it has to wait again. So the waiting time for P1 is 9, 0 plus 9. For P2 it is 0 because at 1 second it arrives and it gets the CPU. For P4 it is 5 minus 3 because it has the arrival, it arrives at after 3 seconds. So it has the waiting time of 5 minus 3. And P3 has the waiting time of 17 minus 2 because it arrives at the end of 2 seconds. So it has the waiting time of 7 minus 2. So the total average waiting time is 6.5 seconds for SJF. So it has very less amount of waiting time in comparison to FCFS and all others also, and also it is optimal scheduling algorithm. The only problem is to need to know about the next CPU burst time. Now look at about the priority based scheduling. What is priority based scheduling? Here each process assign a priority and schedule highest priority first. All processes, if some processes have the same priority, then it will execute as FCFS, first come first served basis. Priority may be determined by the user or by some default mechanism. The system may determine the priority based on memory requirements, time limits or other resource usages. But some problem occurs when other scheduling algorithms happens. Starvation. Starvation is a problem where if a low priority process never runs. This is the problem of starvation. If the processes comes and needs to execute on the priority basis, and some process have the very lowest priority, and if it is get the CPU, then also if some process come which has the highest priority, then the CPU will take over by it and the low priority processes will never execute. This is the problem which is called starvation. The solution of starvation is aging. Aging is a mechanism which occurs, which we do that we for a low priority processes, after certain amount of waiting time of it, we change its priority, and one step we increase the priority of that process by 1. This is the solution of starvation, which is called aging. A delicate balance between given favorable response for interactive jobs but not starving batch processes. Now look at the example of priority based scheduling. We have 5 processes, P1, P2, P3 and P4, P5. They have different amount of service time and different priorities. First, the highest priority is of process P2. That's number 1. It is on number 1. So P2 will execute and it is only execute for 1 second. So after that, the highest priority is of process P5. So it will get the CPU, and after 5 seconds, the next priority process is P1. It will get the CPU and it executes till 10 seconds, which is the service time of it. And after that, the P3 process will get the CPU because it is on the next priority, and that after completion of P3, P4 will get the CPU. So here the average waiting time is for P1 it is 6 seconds because 1 second P2 is execute and then the P5 will execute for 5 seconds. So the average waiting time of P1 is 6 and P2 is 0. For P3 it is 16. For P4 it is 18, and for P5 5 it is only 1. So the average waiting time here is 8.2 seconds. Now next is round robin scheduling algorithm. This is also a very good algorithm. Use a timer to cause an interrupt after a predetermined time. Preempts if task exceeds its quantum. It has a certain amount of time fixed, just like a timer, and it interrupt the CPU and take the CPU from the algorithm, from the process, if that amount of time occurs or it exceeds the amount of time. There are certain terms associated with this. First is context switch, which is it changing the processor from running one task or process to another, implies changing memory. Processor sharing, this is a concept also in round robin, which is the use of a small quantum such that each process runs frequently at the speed of 1 by n, because we have to keep the timer or quantum of a small amount of time, a small amount of seconds, otherwise all the processes will not get the CPU. So we keep that very small amount of time, quantum time, so the user will not get to know that which the processes are not getting the CPU. It frequently go from one process to process, so it should be very small. And reschedule latency. Reschedule latency is how long it takes from when a process requests to run until it finally gets control of the CPU. This is called reschedule latency. The process requests the CPU, but in what amount of time it gets the CPU. That. Now next is choosing a time quantum. It is a very good question how to choose a time quantum. If it is too short, inordinate fraction of the time is spent in context switches. If the time is too short, time quantum, then the context switch time is very large, because it has to do more frequently context switches. If the time quantum is too long, then reschedule latency is too great. If many processes want the CPU, then it is a long time before a particular process can get the CPU. This then acts like FCFS, of course. Look at the example of round robin scheduling. We have 3 processes, 1, 2 and 3 in the VD queue, and their service or burst time is 23 and 4 respectively. We have the round robin of 4 quantum. So P1 will get the CPU first and it will execute till 4 seconds. Then P2 will get the CPU and it will execute. It has only 3 service times, so it will execute till 7. Then P3 gets the CPU and it will execute 4 seconds, and then again P1 will get the CPU. So here in this case the average waiting time is, for P1 it is 0 plus 11 minus 4, because it has already executed 4 seconds, but again it will get the CPU at 11. So its waiting time is 11 minus 4, and the waiting time of P2 is 4, and for P3 it is 7. So the average waiting time is 6 seconds only in round robin scheduling. Let's come to multi-level queue scheduling. In these there are multiple queues. Each queue has its own scheduling algorithm. For one queue it may be FCFS, for second one it may be round robin, for third one it may be SJF or any other. So each queue has its own scheduling algorithm. It has multiple queues, and then some other algorithms arbitrates between queues and can use the feedback to move between the queues. Method is complex. This method is very complex because it has so many queues, and every queue it has its own algorithm for scheduling. So it is a little complex, but it is flexible also. For example, it could separate system processes, but interactive, batch, favored, unfavored processes. It can separate by having different types of scheduling algorithms for each type of processes. So this is an example of scheduling, multi-level queue scheduling, student processes, batch processes, then interactive processes, and so on. Just like that, the system processes have the highest priority, and the students or user processes have the lowest priority. Multi-level queue scheduling algorithm works. Next, multiple processor scheduling. Now, what is multiple processor scheduling? There are many processors, but there are different rules for same type of processors and different type of processors. So different rules for homogeneous and heterogeneous processors. And load sharing is there in the distribution of work such that all processors have an equal amount of time to do it, so that load is shared by different types of processors. There are multiple processors and the CPU shares the load between them so that each processor will get equal amount of work and no one will sit idle in that case. Now, real-time scheduling. What is real-time scheduling? There are two types of real-time scheduling: hard real-time systems and soft real-time. So in hard real-time systems, it is required to complete a critical task within a guaranteed amount of time. Whenever a task is given to hard real-time systems, as a limited amount of time is also given, and within that time frame the system has to complete that task. And soft real-time computing, that requires that critical processes receive priority over less fortunate ones. In soft real-time, we have the processes, we have the time, but if some higher priority processes comes, or there are higher priority processes in the queue already, then that processes will get the CPU first, and you switch between high priority and low priority processes. This is real time scheduling. Actually, these two types are real time scheduling. It executes. Now, what is time sharing and real time scheduling? Actually, in the time sharing, prioritized credit based process with most credits is scheduled next, which has more prioritized, and it will execute the first, and then the CPU is shared by any other process. Credit is subtracted when timer interrupt occurs. I know there is priority between of the processes are set, but we don't want to get the processor in starvation, so we do apply aging also with the time, so that low priority processes also get a fair chance to execute. So the credit is subtracted when the timer occurs with a limited amount of time. In the aging scheme, the priority of the low priority processes gets increased by 1, and this way it works. Now, what is real time scheduling? In real time or in soft real time, two classes are there: FCFS and round robin, and highest priority processes run fast in this way. Soft real time also, the highest priority runs fast, as I already discussed about it. Otherwise, there are some classes of real time FCFS and round robin, mainly scheduled between these by these type of. Now, what is the how do we evaluate, how we decide which algorithm is best for a particular environment? Which type of algorithm is best? This is determined by deterministic modeling. It takes a particular predetermined workload and defines the performance of each algorithm for that workload. That modeling works. Queuing modeling works, and this by using these models, queuing models and deterministic models, we decide which algorithm is suitable for our execution, our environment. In this sense, for example, we apply all the processes by all the algorithms one by one and check whether which is suitable for which, by the SJF, FCFS or round robin, which is suitable for our algorithm. And this type of the thing we works. We take the average amount of time, waiting time, response time, all the criterias are taken, and then decide which is best for us, for our environment. In this way the algorithm works. In this way the scheduling works of a CPU. So this is all for today. We had discussed FCFS, SGF, round robin priority scheduling, multi-level and multiple processor scheduling. All these type of scheduling we have discussed. I hope you understand what I am trying to explain you. I hope you like the video, and please do comment whether it is useful for you or not, and try to subscribe our channel to get the latest updates on various subjects, whether it is operating system, TOC, computer networks, or artificial intelligence. We are soon going to upload more videos, so try to get connected, try to get subscribed with us. Thank you. Have a nice day.